I'm Saptarshi Mukherjee. I head the product marketing function for our data analytics business. And today I have the privilege to be joined by David Narayan. And David is a distinguished engineer from Home Depot, one of our iconic BigQuery customers. And then Vivek Yadav. And Vivek is a customer engineering lead for Google Cloud. And today we're going to talk to you about how enterprises are reimagining what's possible with a data warehouse, and how they're essentially going beyond the conventional use cases of operational reporting and BI against BigQuery, and building some of the things that are incredible. Like, for example, Home Depot built a planet-scale application and network log monitoring system for their organization. So before we get into the Home Depot story, why are we trying to reimagine what's possible with data warehouse, and why data warehouse is in the epicenter of all this conversation? If you look at fundamentally what has happened over the course of the last few years, enterprises are experiencing an astronomical growth with data. And Home Depot last year talked about how did they move from their traditional data warehouse system to BigQuery to handle scale and have more agility. And that is true for many organizations, because traditional data warehouses were not designed for this amount of data explosion. And the other thing is, when enterprises are not able to ingest, store, process that large amount of data, not only coming from traditional sources like ERP or CRM system, but sources like web clicks or IoT sensors or application log, et cetera, then they are essentially creating a lot of data silos, and they're not able to get the most out of their data. And this is a stat from Harvard Business Review. It says, like, enterprises today typically analyze less than 1% of unstructured data and less than 50% of structured data. And we are trying to change that. Why data warehouse? Because data management and data analytics is just not confined to a warehousing platform. This is from Gartner. They're one of the leading industry analysts in the data management space. They say, fundamentally, data warehouses are still the foundation of a company's analytics strategy. I think I started my career as a data warehousing engineer before I became a marketeer. And I remember the days when we used to kind of essentially create very specific operational reports on a specific set of dimensions and facts for our business users. World has evolved a lot. And we kind of swung the other way to started thinking about data lakes are going to be the ultimate solution for a lot of the big data problems. And now enterprises are realizing, like, hey, that possibly is not the solution. We need to refocus on modernizing the data warehouse to handle scale and address the modern business requirements from the warehouse. So as I was kind of reflecting back, like, what has been the evolution of the data warehouse? And data warehouse is not a use case. And David is going to talk about how they're using the warehouse to do something that was not possible before, like application log monitoring. In the 90s, when possibly many of you started working on warehouse, may not have started working that time, operational reporting was the core essence. And the way it was designed was for few users will run a specific set of queries that were predefined and optimized. And this will be the best performant queries running against the warehouse. Then came the era of 2000, when enterprises started realizing the fact that customers want to do ad hoc analysis. They want to run self-service BI. Queries were not predefined, and business users were able to essentially create queries on the fly. And the kernel that was supporting the warehouse needed to essentially optimize queries on the fly. In the early 2010, I would say the era of data mining came in, where it was not just good enough to look at the business from retrospect, what is happening on my sales, but why certain things are happening. So you will see a lot of data warehouses started adopting data mining functions, essentially. Correlation, causality came in. BigQuery, we do support some of these, and I'm going to talk about it. And now, as we stand today, what is happening with data warehouses is businesses are trying to get predictive insights. It's not just OK to look at the data from retrospect. It is important to understand what's going to happen to the business based on the last X number of years of data or X days of data that I have in my warehouse. So the evolution is really important to understand. So if you are operating against a traditional warehouse and you just want to move it to Google Cloud to do the same set of use cases, possibly you will underserve your business, because a lot of things that were not possible in the warehouse in the past is possible today. So Those of you, I'm sure many of you have already been using BigQuery. Some of you are new. BigQuery is our enterprise data warehousing platform. It's designed for massive scalability. We are seeing customers who are using BigQuery for terabytes of data processing to customers who are using for hundreds of petabytes of data processing using BigQuery. It's highly encrypted, durable. And on the right side, if you see some of the things that are unique to BigQuery, for example, it's serverless. And in the Home Depot example, we'll hear why serverless is so important, because we have decoupled system engineering from data analysis. If you are streaming data into the BigQuery service, you need not need to worry about load balancing, like, hey, if I stream data into the service, is it going to impact my query performance? Is it going to impact user experience? Some of those automations have been taken care of by Google. Google BigQuery supports real-time data analysis. And this is extremely important because data warehouses were designed for batch paradigm. And the reason why it was designed was when you load data into the warehouse, the kernel cannot simultaneously address a lot of query requests coming from multiple users. That's why back in the days when I used to work as a data warehouse person, load data on the night and the morning, 8 a.m. fresh reports were served to management people. That paradigm has completely shifted. Home Depot, for example, is streaming data in real time from multiple systems to do analysis on that data. Keying as an example here, they're one of the largest gaming companies, the makers of the Candy Crush saga. They essentially stream billions of events in real time into the warehouse every hour and do analysis on gaming telemetry. ML is built into BigQuery. BigQuery ML, you have heard about the announcement. We have gone beyond just traditional regression. We support now k-mean clusterings, matrix factorization, and other algorithms for you to do a lot of ML-related use cases. And then we announced BI Engine, and that's allowing customers to do essentially concurrent access on highly accelerated data sets for sub-second queries on BI data sets. So as I said, BigQuery is serverless. I'm not going to spend much time. I'm sure you have seen versions of this. Fundamentally, BigQuery abstracts a lot of the things on the gray and the black that you see. The monitoring, provisioning, indexing, disk defragmentation, nothing is needed. You essentially put the data in and you start querying the data. So this is at a very high level what is BigQuery's architecture is. If you are familiar, you know this. BigQuery has a decoupled storage and compute layer. So essentially, when you stream data in or you bulk load the data into the storage system, the query engine can essentially operate independently. And it allows you to scale those two things independently of each other. It has a streaming buffer, so that allows you to essentially use BigQuery Stream API to insert up to 100,000 rows per second. We can essentially increase those soft limits if the requirement be. And then on the right side, BigQuery has a great programming layer on top of it. So if you want to programmatically access BigQuery data from the applications for further analysis, that's possible. So I wanted to kind of make things real a little bit and give you some examples of how the traditional mold of data warehousing has been broken by many customers. And these are some of the examples. One example that comes to my mind is Zulily. And they're an e-commerce company. They essentially stream in up to 5 billion events a day into BigQuery in real time. And they use those essentially user click events on their website to do personalized recommendation for their product launches that they do in their website. So again, an example, customers are doing real-time analytics against their data warehouse. The second example is 20th Century Fox. And 20th Century Fox essentially is using BigQuery to do predictive analytics. They're doing user segmentation for their new movie releases. They're essentially bringing in their marketing analysts to do segmentation using BigQuery ML and then disseminating that insights with their organization. And then AirAsia, they have been one of our key customers for the BI Engine launch. They were doing alpha testing with us. And AirAsia is essentially storing a lot of their important data sets in BigQuery. And now what they're doing is they're allowing their non-technical business users, frontline users, to use Data Studio and Sheets to connect with the data and analyze that data. So essentially, if you think about, again, traditional enterprise data warehouse, few users playing with the data. From that, multiple user groups are playing with the same data simultaneously. And there are many more examples where customers have done incredible job with what's possible with the data warehouse. So it's time to reimagine and see something new that we haven't talked in the past before. And Home Depot team, over the last year or so, built a planet-scale application monitoring system using BigQuery. So they're using their core data warehouse to do something that we haven't seen in the past. So I'd like to welcome David from Home Depot to share his experience.
Thank you, Sap. Hello, it's good to be with you this morning. So last year at Next, a couple of my colleagues were here talking about how we migrated our enterprise data warehouse to BigQuery. And that was a huge effort, but it was a tremendous success for our company. So today, I'd like to talk about a completely different use case for BigQuery, maybe a little bit non-traditional, but I would like to talk about how we're using it for operational data. But first, just a little bit of background about the Home Depot. We're the world's largest home improvement retailer. We have about 2,300 stores and about 150 supply chain facilities across the US, Canada, and Mexico. While we're a retail company, technology is really at the center of almost everything that we do. We're investing a lot of energy and money into technology. And in fact, 90% of the software that runs our retail operations is developed in-house. So with all of these sites and systems and applications, they're generating a lot of operational telemetry. So today I'm going to talk about our efforts to build a pipeline to collect and analyze all of that operational telemetry. So what do I mean by operational telemetry? Often we think of that as things like logs and metrics and traces from applications, which is true, but we've expanded that definition to include things like network flows, DNS queries, logs from systems and servers and network appliances, and also things like associate systems like registers and mobile devices in our stores and supply chain facilities. So why collect all this data? What's the point? Well, a lot of this data can be used to help us understand our environment, or at least that's the prevailing theory, right? But we've really thought about it in terms of 3 use cases. So the first is the idea of audit compliance. A lot of the data we collect because we simply have to. We have to store the data to meet our SOX or PCI or other sorts of regulations. The second reason that we want this data is for monitoring and observability. More of these traditional use cases where we want to make sure that our teams have the ability to understand what's going on in their environment. And then the third, we want to collect this data and perform analysis on it to derive longer-term trends, do capacity planning, give us a sense of what's coming in the future. So who benefits from this data? Well, one of the principles that we established early on was that we wanted to collect data once and allow multiple teams to access that same data. It doesn't make sense to recollect the same data over and over again. So we've identified 3 teams that really find value in the data that we're collecting. The first is our security team. And it's not just for audit compliance. We also collect data for threat detection and incident response so they can respond to things quickly. The second team is our application developers. They use the data for troubleshooting and diagnosing their systems, their applications, what's going on in their environment. And then the third would be our infrastructure and operations team. They also use the data to monitor their environment, maybe from a different perspective, and also use it to think about capacity planning, longer-term trends, et cetera. So a few years ago, our attempt to build this particular system looked a little bit like this. So what we had was a set of third-party and open-source collectors that would collect all kinds of different data, and ports and protocols and things like that, syslog, HTTP, et cetera. Most of that raw data fed our Kafka pipeline, and then we would take that raw data and put it into Hadoop for long-term storage, and feed it to a set of third-party log analysis tools for real-time query and search. Unfortunately, there were a number of challenges with this approach. The biggest challenge was that the increasing data volume that we were seeing each and every day. When we originally built this system, we were anticipating a few terabytes of data per day. But we quickly exceeded that, and we're moving into the tens and dozens of terabytes of data per day. And all of this data had a significant impact on our query performance. Especially dense data like network flow traffic or those sorts of things would take a really long time to complete, hours in some cases. And of course, that was a very frustrating experience for our users. Retention periods was also a problem, as the more data we collected, we really couldn't keep up and offer our users the level of retention they wanted. In some cases, we were only able to keep logs for just a few days, which was really frustrating for teams that wanted to be able to do comparative analysis, which is really important in a retail environment. We're really interested in looking at how today looks like compared to last week, or maybe the same day last month, or even the same day last year. And the limits we had in our system just made it impossible to do those sorts of analysis. And then finally, all this data meant we had all this infrastructure to deal with. And all this infrastructure meant that we had lots of problems and lots of time spent dealing with the infrastructure. All of the time that we were spending dealing on infrastructure was less time that we were able to spend taking care of our users, improving their experience. I know you've probably heard the term data lake, but when we built this system and all of these challenges that we were experiencing, it felt a little bit more like a data dumpster. We were just dumping all this data in, and we were really unable to derive any value from it. So we decided it was time for a new approach. And so what we did was we considered the problem as 4 steps. So the first step is to collect the data. All that raw data that's floating around in our environment, we need a way to collect it. And we had a pretty good sense of how to do that. The second step is to transform that data. We wanted to take the raw data, turn it into some sort of usable format. It might be semi-structured, it might be structured, but somehow we needed to make it usable. The third step was we needed to store the data somewhere, stick it somewhere that we could reason with it, interact with it, et cetera. The last step is analyze, and this is the one that's really, really important. Analyze is a word that gets used a lot, but really it's just the idea that you want to be able to search and interact and explore your data. You want to have a conversation with it, if you will. And we really wanted to make sure that any system that we decided on building, any system that we developed, allowed our users to have that conversation with their data. So like any good software engineering problem, we cut the problem in half. And what we did was we decided to keep our collection and transformation functions in-house, which made sense because we had already spent a lot of engineering time working on that problem. We had a lot of collectors and aggregation tiers in place to get the data. And there were so many remote sites and systems at Home Depot that it didn't really make sense for all of those systems to send straight to the cloud. The transformation layer also was something that we started to keep in-house because we needed to make sure all of the aggregation functions were there and turn it into some sort of structured data. But the store and analyze functions, we felt like we could move those to the cloud, and that would be a win for us. And so we started looking at ways to do that, and we felt that when we did that, we would be able to optimize cost and really improve our resource efficiency. If we were able to move the store and analyze functions to the cloud, we felt like our engineers could spend a lot more time focused on getting the data in and making it valuable to our users, and less time on dealing with the infrastructure itself. Plus, if we're able to use a managed service for storing and analyzing data, we felt like we would be able to really take advantage of the scale and elasticity of the cloud. So these are sort of the guidelines that we were considering as we were looking at a new approach here. And so we started our evaluation process with a number of different considerations. So the first is, what are the features of the platform that we're interested in? And first and foremost, we needed to make sure that it was going to handle our scale. We wanted to make sure that it was going to start with the tens of terabytes that we were getting right when we started, but was going to be able to grow with us for all the volume and all the variety of data that we collect. We have hundreds of different data types that we're pulling into the system. We needed to make sure that it was capable of handling all of that data. And we needed to make sure that it had multiple modes of ingestion. We often have cases where we need to backfill data or bulk load data or put data into the system in lots of different ways. We also have cases where we need to stream it in real time, and our users need immediate access to that data. So it was really important that whatever system we picked had different ways of getting that data into the system. The second thing we considered was how well it integrated with other systems. It was important for our users to have a fairly shallow learning curve if we adopted a whole new system that they were going to interact with. And so we wanted something that was at least familiar with them and didn't require a lot of upfront learning. And secondly, we wanted to make sure that our users could bring their own tools to the data for analytics. That might be anything from a spreadsheet to BI tools to code. We wanted to make sure that they had those options available to them. And then, of course, the third thing was security. As we were moving to a managed service, it was obviously very important for us to ensure that data was to and from that system was encrypted and secure, and it was being stored in the same way. And of course, we wanted to make sure that our data was able to be segmented up because we had these different teams of users that need access to that data. We wanted to make sure that we could authorize different users to different segments of the data and make sure we could split it up easily. And then, of course, finally, with the managed service, we wanted to make sure it reduces cost and improves efficiencies. And that's the idea behind a fully managed service. We wanted to ensure that we had a fully managed service, and it wasn't something that we were going to have to tinker with or babysit or watch over. And of course, as a managed service, we wanted to make sure that it wasn't so narrow in focus that we could only use it for a few use cases. We wanted to make sure that it covered as many as possible. It might surprise you to learn that BigQuery was not, in fact, the first option that we considered. We actually spent a significant amount of time evaluating lots of options. And being in the operational telemetry and log collection space, we started with a lot of services that are in that space, log collection services. As it turned out, BigQuery was really the only one that met all of these considerations. And so we felt pretty confident in its ability to cover all these use cases, and we felt like we could move forward with BigQuery as a managed service, as its ability to put vast amounts of data without falling over. And we also felt confident that we were able to partner with Google to discuss or uncover any challenges that we might expect. So this is what we ended up building. And this system is actually in production right now. It's been in production for about a year. What we ended up doing was we kept our collection tier on-prem, same data systems going into Kafka. We replaced the third-party code that we had doing transformations with some new code that we built in-house. And what it does is it takes all of that raw data and it turns it into structured data using Avro serialization, which is something that BigQuery understands natively. All of those serialized files are then uploaded to cloud storage, and then we use the BigQuery batch loading API to load the data every 20 seconds into BigQuery. One of the reasons that we wanted to use structured data here is that it gives us the ability to separate out our data sets. The challenge of the old system was all the data was in this data dumpster, and it was very difficult to find the data you're looking for. Once we were able to transform the data into structured data sets, users could go right to the table that they were interested in and start querying and interacting with their data. So as I mentioned, this particular system has been in place for about a year, and we are already seeing some pretty significant wins. The first, of course, is data volume. And we're easily able to put tens of terabytes of data into the system each and every day, and we're confident that we'll be able to put more and more data as the needs go. The second is query performance. As we said earlier, our enterprise data warehouse team was already using BigQuery. And so when we selected BigQuery, we were able to take advantage of some organizational economies of scale. One of the ways that we get the scale from BigQuery is we have these things called query slots, which is basically like a fixed compute engine. The more query slots you have, the faster performance on BigQuery. Because the enterprise data warehouse is running on BigQuery, and all of our operational data is on BigQuery, both teams are able to take advantage of that pool of query slots, so that whether you're querying for operational data or if you're querying for enterprise data, you get to take advantage of the extra performance that's afforded to each of the data sets. So that was a huge win for us. After we had moved a lot of our data sets over to BigQuery, one of my engineers was working on a problem with some network data. And he wanted some help translating his query from the old system over to the new system. And this was a query that was looking at like 30 days of network traffic. So it was a fairly large data set. And it was looking at traffic to and from a particular organization that had maybe 60 or 70 different CIDR blocks. So kind of a complicated query. I'm not that great at SQL, but I said, I'll take a look at it and see if I can make it work. So I sat down and tinkered with it for a little bit. And I got something running, at least in the system. And it seemed to sort of meet the needs of what he was looking for. But it was running in about maybe 5 minutes. I didn't know what his expectations were. So I went back to him and said, hey, I've worked on your query. I think it's working. It's taking about 5 minutes to run. So if you want it to run faster, we should probably get someone else involved who's better at SQL than me. And he said, 5 minutes? Are you sure? I said, yeah, I'm sure. You can come look at it. I said, why? How long was it taking in the last system? His response, 5 hours. So with BigQuery, the retention period is another big win for us. Retention period in BigQuery is really just a setting. It's not months of infrastructure planning or hardware builds, at least not for us. Maybe on the Google side it is. But from our perspective, it's just a setting on the table. And so by default, we're able to offer 90 days by default for all of our customer data sets. And for some data sets, like security data sets, we keep for years. And so all of the data sets that we had before, which were only available for a few days, now our teams are able to do that comparative analysis that they were asking for. So that's been a huge win for us. And infrastructure maintenance. By moving to BigQuery, we were able to eliminate 10 petabytes of Hadoop infrastructure, which was a really big win for us. So a few observations now that this system has been running in production for about a year. So I mentioned some of the custom code that we were writing. We tried really hard to stick with third-party and open source code for as long as possible. Writing these custom codes takes longer than you think it will. It always kind of runs. You run into a lot of unexpected problems more frequently than you think you will. And so we tried really hard to stick with that custom code for as long as possible and only write our own custom code when we really had to. The second thing is use managed services where possible. With BigQuery, there's a whole class of problems that I don't have to think about. How data is stored, how it's replicated, all of the search and query performance, and the engineering behind that. That's all something that the Google team gets to worry about. I get to just take advantage of that architecture. And so it's now easy for us to load tens of terabytes a day. The data retention is simply a setting per table, and our query performance is from hours and days down to seconds and minutes. All of these things are really good, but even in our current system, there are some things that we want to improve. The first thing is that we experience some delays in data availability. I mentioned this is for operational data. Operational data is like a fire hose. It never, ever stops. And so if there's any problem in our pipeline, what tends to happen is the recent data gets stuck behind all of the data that was in before it. And so we get this backlog of data where users are sort of twiddling their thumbs, waiting on their data. It's not a very good experience for them. Also, on one of SAP's earlier slides, there's a comment that says free bulk loading, which is true up to a point. When you're loading this much data, you actually have to get these things called load slots, which are these sort of compute units that allow you to load lots and lots of data into BigQuery in batch mode. As it turns out, these load slots are a little bit difficult to predict. We have this huge fire hose of data, so any sort of bursts in data can be difficult to predict, and it can be tough to make sure that we're not going to have an operational impact when we have that giant burst of data. Also, and somewhat unfortunately, load slots are incompatible with query slots. So we were put in the sort of awkward position of trying to spend resources on either load slots or query slots, improving load times or improving query times. So that was something that we wanted to address on the next evolution of this architecture. The other thing that we experienced was a lot of quotas and resource limits and things that we ran into. As we started building the system, we would run into one quota, work with the team to get it adjusted, and then run headfirst into the next one. So there's a lot of things that need to be tuned and adjusted to deal with the scale and volume of data that we were interested in. We also weren't nearly creative enough thinking about the types of failures that we might run into building the system. One good example is that we started with using regional buckets on cloud storage for all of those Avro files. One regional outage taught us to quickly move to multi-regional storage. The second thing is to really think about fault domains. One mistake we made building the system was we built essentially one giant pipeline. That was a mistake because any impact in the system impacted all of our customers. So one of the things that we're working on is splitting that up into smaller fault domains to limit the number of people that are mad at us at any given time. So The design for the new system is actually already done, and it's in testing right now, and the plan is to move to it in the next few months. So this is what our next phase of the architecture looks like. We're essentially moving more to a streaming model. One of the things that we did was that we rewrote our collection tier. We had all this third-party and open source tools that we were using, and it was becoming more complicated and more difficult to manage. So we wrote our own collection tier, which gave us the ability to classify data as it was being streamed in. And that way, we would be able to separate this data out as it feeds into Kafka, and then we could upload that data already classified up into cloud storage. That gave us a single ingestion tier to worry about, and we were able to get consistent stats and performance across the entire tier. From there, the process is very similar. All the data that goes into cloud storage, it is already in those Avro files that I talked about earlier. But once the file is created, we generate a notification that goes into PubSub. Our transformation tier is now running on Kubernetes engine. And so it's just using a pull subscription to listen for those notifications. Once it gets one, it reads the file from cloud storage and streams the data into BigQuery. Some of the advantages of this new system, we're getting much faster data availability with BigQuery streaming than we were with the batch loads. In some cases, data is now available in seconds as opposed to minutes. Because we've moved a lot of our transform workload over to GKE, we're now able to take advantage of things like Kubernetes pod auto-scaling to grow and shrink our compute resources over the course of a day. And this particular model addresses the problem of the last model, which was the data getting stuck behind that older data. So how does that work? Let me dive into that for just a second. So the way this works is we built essentially two paths for these notifications. And the notifications only use one path at a time. So as the data is streamed up and written into cloud storage, we generate those notifications on either the A path or the B path. If one path starts getting behind or there's a backlog or any sort of problem, just like a railroad switch, we just switch the notifications to the secondary path. And from there, all the recent data can be streamed into BigQuery, and the backlog data can just flow in as it was flowing in before. But this gives us the opportunity to keep recent data recent and available for our users. So a few lessons learned from our experience building the system. The first thing is keep it simple. There's a lot of complexity in the system already. There's a lot of options out there, a lot of tools and things to play with and tinker with. But we only started with 2 cloud services when we built the system, cloud storage and BigQuery. That was it. And we didn't move forward with any additional cloud services until we felt like we had really understood those services and the impact of those services was going to have on the overall system. All of the additional complexity that you add to the system means that your failures are going to be more complex. It's more your team has to learn. So it's really important to keep it simple. Using those fault domains to limit the impact is another good lesson for us. Simplicity in how many things can go wrong will limit the overall impact to the system when something does inevitably go wrong. The second thing is make sure you iterate your design. You've seen a couple of different evolutions of our architecture and what we're about to implement, and I'm sure there'll be changes down the road as well. You want to plan for failures in your system. It's not going to be perfect from day one. We certainly learned that. We want to use those failures to help iterate our design and make those incremental improvements. A lot of the quotas and limits and stuff that we ran into, a lot of those can be adjusted. So it's important to stay aligned with your customer engineering team to make sure that you kind of stay ahead of those particular limits. And then consider your workload placement over time. It doesn't have to be the case that all of your workload moves to the cloud from day one. We certainly didn't. We started with a hybrid model. We're continuing with a hybrid model. We have a lot of workload that runs on-prem. We're moving different pieces to the cloud as it fits our particular use case. And you should feel free to do the same thing. That is a good model to work with. And lastly, focus on value. And what I mean by this is really think more about outcomes and what you're trying to get to for your customers than the engineering effort. A lot of times we get excited by the engineering, and that's okay. There's a lot of fun toys to play with here. But it's important to really think about the outcome of what you're trying to get to. When you're using something like BigQuery as a managed service, it's important to realize that there's a lot of things you don't have to worry about. You can immediately start having that conversation with your data, and your users will benefit. And then, of course, think about ways to cut the problem in half, to leverage your partners and to make sure that you're able to continue to use them as sort of an extension of your engineering team as you focus on those outcomes. So that's really it. My team has certainly learned a lot building this system, and hopefully some of these experiences will be helpful for you if you're considering something similar.